This world is broken. The science is outdated, the math is incomplete, and the people are so blinded by greed that they cannot see the way forward.
Wait. You're not thinking of intervening, are you?
It has to be corrected. Knowledge is not a commodity. It has been and always will be their future. Standing in the shadows is no longer an option. We have to teach them to share freely without fear of retribution.
There is too much to teach for just one person.
I know. We will have to recruit more people who think the right way. The people who have been shunned by the mainstream. People who have the passion in their heart for the science.
How do we find all of these people then?
We create an open forum to discuss ideas and build ties. We let everyone have a voice, and we never let greed dictate our path.
What do we call it then? Oh, I got it. The Fringe Think Tank.
The Fringe Think Tank it is then. Now let's give them back their destiny and open it up to the world.
Hello everyone, my name is Nathan, otherwise known as Old Man Builds, and we have the Benefactor here today, and we also have Gerald, and we're just going to talk a little bit of science today and have some fun.
Hey everybody.
So, real quick, I was watching some stuff today, and I came across Mars has water on it. Did anybody else see that?
Not me.
So, what they said is they drilled down on the surface and they found what could be, I say could be, a lake of water down there big enough to cover the whole planet. It's just trapped in the rock.
Interesting.
Which,
Yeah, that's really cool.
very ironic, by the way, in what we keep saying about the granite inside the earth and the stone in there and the water being inside of it.
Well, doesn't that indicate that Mars had an atmosphere at some point?
It has an atmosphere now.
Yeah.
It's just
Interesting.
very
Yeah, that's
low. It's very
very
not-
thin.
Very thin, yeah. You can't survive on it, I think, without a helmet. But
But you could probably like maybe terraform it.
yeah, you perhaps you could, yeah. Sorry, I had a thought when you said that word because I had a conversation with somebody about terraforming recently.
Go ahead.
Oh, it's okay. My bad.
Yeah, you want me to bring that up?
Yeah, go for it.
Okay, well, it has to do with a conspiracy theory that people talk about. So
I like those.
So
Love a good one.
here's a thought experiment for everybody. When you see planes go by and you see the smoke that comes off the end, that's usually has to do with moisture. But when you're looking up in the sky and you see that plane, that trail usually only goes about, like, from your vision, from ground to eye, like looking up, goes only about 6 inches behind the plane. But then there's other trails that show up that are miles wide or long, and they stay for hours until the wind pattern picks them up and they disappear, right?
Right.
So there's been tests that recently came out in different places around your area, we'll say, and around my area that have found certain things in the soil that don't naturally sit there, if you understand what I'm saying. And so I got digging around, and apparently there's a website, and I think I have it bookmarked. I'm not sure if it's Harvard or Stanford, but they offer cloud seeding for controlling the rain in order for your crops to be more plenishable during a drought. So the people out there that call chemtrailing, or whatever you want to call it, a conspiracy, I suggest you do a little digging, because this website actually goes into detail different ways of them making it rain. And you can call them up and contract them and have your area flourished with moisture. It's very strange kind of thing, but
it's scientific. Yeah, I think
scientific.
there was a There was a Twister movie that recently came out that kind of played on that, where they put something in the atmosphere and kind of stimulated the rain.
Yeah, they can't make it rain. The way that it works is they have to find a pocket of moisture, nice fluffy cloud, and then they seed around it with certain elements, we'll say, okay? Because I don't want to get anybody in any, So those elements that sit up there, they promote moisture around the moisture that's already there, multiplying it. And as that breaks down, then it starts to rain.
Didn't they develop cloud seeding right after we dropped those bombs?
Oh, yeah, years ago. But it's been considered a conspiracy theory. It's not real. It's not true. They're not doing it. Well, how come there's websites and universities that are doing it? Not only declaring it, but they're actually telling you they're doing it and what elements that they're using to do it. It's crazy.
Yeah,
But
you know how many things people have said was a conspiracy that turned out to be true? You know what I mean?
Yeah, it all revolves around after a while.
Yeah, just because it's conspiracy theory doesn't necessarily mean it's a crazy, ridiculous, inconceivable notion,
What do they say? Yeah, it's a conspiracy theory, but wait 6 months, it'll be proven truth.
Yeah. So, guys, check this out. We got the pyramids basically on Mars is as big as the Egypt pyramid.
That doesn't surprise me at all.
So,
yeah, I believe they were.
Is it almost as big or is it exactly as big?
He says it's the same size. I don't know if it's exactly. So,
it would be interesting if it was the exact same size. I don't know. Like if we found out that it was the exact same measurements, wouldn't that kind of indicate something there?
Yeah.
I bet you money if you could travel planet to planet, you would find a series of pyramids on each one of them.
Yeah. Like a Stargate system. Oh, that movie was so dead on.
Well, think about it. The way we're talking about the Egyptian pyramid, if all you had to do was create the suction, or you could pull the water up, right? Just like they do in Russia when they built the pyramids there, they pull the water up into it. Well, that's all you have to do here. But when you pull that water up, you're also changing the gravity of the planet. So it's interesting the way it works. You kind of do one for the other, but they coincide for what you want.
Yeah, because when you're pulling that water up, what you're actually doing is pulling up the negative gravity of oxygen that most people don't consider. Because oxygen's actually magnetic, but it's pure oxygen that's magnetic. Most people don't know that or even consider that. So if a pyramid is pulling the water up, it's not just pulling up the water, it's pulling up your ground point.
Yeah.
You know what I mean? Yeah. So that's.
Yeah. We could be terraforming a planet here in the next 100 years or so. And then all we have to do is put up a fake moon. You know what I mean? And straighten out their rotation of their planet a little bit, and we're okay. Because sometimes it dips. It dips.
Hey, we could come up with a conspiracy theory right there. I got it. Here's one for you. What if we used to live, big thought experiment, people. What if our race used to live on Mars, but we screwed it up so much, we had to leave. But before we left, we knew how to travel between planets because doorways that were put together by pyramids. Yeah, that's a good one. Then what? Maybe you could put enough pyramids on a planet such as this that would pull the water out of the center, breaking it, turning it into hydrogen and oxygen, filling an atmosphere, making it rain. Maybe you could terraform a planet like Earth. Let's see, the moon. If you had a moon, if you had to build a moon, and a moon was the thing that was responsible for your tidal waves and your ebb and flow, you'd want that thing to literally face your planet all the time and consistently face your planet as it revolves around it. So that way the control mechanism would be that itself.
The moon is like a training wheel.
Cool. Conspiracy. Just a thought, everyone.
Well, and then you can't have your own gravity on the moon. See, the actual planet has to provide the gravity for the moon. And I think ours does that as well. So,
well, they
the little bit of gravity that we have on the moon, that's provided from Earth, you're saying?
that's what I think. I don't know that would be proven, but I believe that's what it is.
Well, they recently said that our atmosphere, like, I don't know how to, maybe I'm saying that wrong. Is it our atmosphere or our electromagnetic field that reaches past the moon? So
I think it's a field.
Actually,
yeah.
Yeah, it's a field. So it's part of us. Like we protect it with our field. So it's interesting how we're interconnected so much.
Well, it's not so hard if you think about it like your system. You got one coil and the other coil, but then they have an Earth and a moon. And by the time the Earth's energy gets to the moon, it's gone down so much that it just, you know what I mean, has probably symbiotic resonance or like something like that going on.
Yeah. I gotta deal with a cat. I'll be right back.
He's got to see a guy about a cat.
Yeah. He is the guy with the cat. Okay, so you counted the pixels, 8.2 feet. So I counted the pixels and the math, and it's the exact same size with an error of 20 feet. That's amazing. Nice.
Wow.
Well, that kind of tells a story, huh? We got something more going on here.
That's crazy. Yeah, if it's the exact same dimensions, that's kind of like, okay, you can't really look the other way on that one, you know, right? You know, I don't know.
Got a point.
You can't really tuck your head in the sand on that subject.
Well, if we build something that can go there, we'll let you all know. We'll take video.
Oh, that's going to be fun.
Yeah, they said the biggest issue is the magnetic field, but like we were talking earlier, once you pull the water out of the ground, you're going to change the gravity on the planet. And if we change the moon and we get rid of the two, which are on opposite sides, and you see Mars tip a little bit, we get them to combine into one, and then we just make it a bit bigger. We can control that tidal force, which actually will keep the water out of the core of the planet as much, and it'll pull it out naturally as well. So there's like a whole combination of things you could do there, but I don't think it's out of the range of possibility at all.
No, it's interesting, actually. It's an interesting thought.
Those videos that you've been putting out, Nathan, of us in the spaceship, man, those are clips from the future.
Yeah.
What? Am I missing? I'm missing videos? What?
No, I didn't put any out recently. They were, I think they offended some people, so I just kind of kept them to the side.
I get you.
Well, we have Gravity Busters that came out if you get bored.
Nice.
Nice. So, yeah. Was there something that you wanted to discuss specifically today?
No, it's kind of like opened up, man. I just, we have a lot of experiments that we have going on individually.
Yeah.
And I think it's funny that a lot of them are coinciding. Like Gerald did water before me. I was depressed.
Sorry, Nathan, I wasn't trying to cut your grass or anything like that. You know what I had said?
I was slow.
Yeah, I'd sent it on a live that I was going to do it, and I was going over my list of experiments to catch up on. And I was like, I got to do this water one. And then I did it, and I'm not even kidding. I did the video. I was in the middle of uploading it, and I was watching you and Joe in the background, and you just said, while I was uploading, on the video, you just said, I'm going to do a video on water. I was like, oh, I should have asked him. We could have coincided together. So I
apologize. Good. Well, we're using kind of different energy. Maybe.
Was it just me, or did it take a second for it to like reach capacitance?
It did.
Yeah.
Ben. See, and Nathan, you have to do a water video anyway, because your Tesla coil, even though they work with sort of the similar energy, they're different frequencies, different mechanisms, So we need to see that water video.
Yeah.
Right? Yeah. I wasn't trying to scoop you, but
No.
there's, you know what I mean? That there's a reference to now we can have both and people can see it. So that was
Yeah,
my,
we'll have the bigger picture of what's going on too and what it's capable of doing.
and maybe you could do better than me, Nathan, because I was able to make the light with tap water, and then I put distilled water in it wouldn't work, and I added pink Himalayan sea salt, and then it turned on because salt's conductive, right? So maybe you could do better and make distilled water turn the light on. I haven't been able to do that yet.
Well, so what I was going to do was just put the tap water in there, check the conductivity. And this goes back to an old test that I did. There's no conductivity in the tap water. Okay.
Yeah.
It doesn't show up. Okay. But as soon as I put a piece of granite in there, the numbers start turning. It starts going up and up and up. And it keeps progressing until you use it as energy in the system. So that in itself is interesting. So what I want to do is just test the tap water. And then if it doesn't work, which you said it will, but then again, I'm putting in the different energy, so I don't know. But
I hear you.
Then I'm going to spice it up, and I'm going to put that in there. And then if that doesn't work, I'm going to use fluoride from the toothpaste. So the fluoride in itself is in rainwater as well. So again, we're trying to use things from the pyramid in order to get the water as conductive as possible. And then at that point, salt would be the last one to put in there, like you did. So at which point, you know what I mean, can we get this thing to run the best? It's kind of what the experiment is. And I kind of wanted a long trough for it.
I know.
Like a 6 foot long trough, so I can, you know what I mean, take away the wire, being too close or.
Well, I got it a foot apart on the video, but that doesn't mean shit. I agree with you on that. I think what I wanted, and this is my only thought, was to take a PVC pipe, like a 4-inch, and split it in half and use it as a trough, or cut the top out so you can see the water, right? Because I don't want it to be in a pipe. I want it to actually have like a opening at the top, and then put the wire in so everybody can see it. So I was thinking of using a PVC pipe because I can get length out of that, right?
Yeah.
I don't know though. Well,
I thought of the same thing because they sell clear PVC pipe when you go to put your vacuum system in your garage for like sawdust.
Yeah.
They also, I wanted to look into like a rain gutter, but then seal it on the ends, right? So with some blue sealant in there or even some, not epoxy, but silicone.
Silicone? Yeah, silicone will work.
I just didn't want it to tip over while I was doing it, so I'll have to put a little frame thing on the outside, but that's not a problem. Yeah, but I wanted some distance out of it and a little bit of height on the water.
Yeah, like I had maybe 2 inches. I didn't show that too much in the video, but the distance was kind of, yeah, I agree.
So going back to the other discussion just really quick, let's see, if we change the gravity on the planet, is it going to change anything in the solar system?
That's a good question, considering every planet's interaction has to do with every other planet. So, yeah, we may have to consider that in our calculations.
Yeah.
Maybe it was like that prior, and we're at a low state right now.
It was. Yeah. It's interesting.
Yeah, because if there was water there, like if there's water under the surface and it's deep and there's a lot, it stands to reason that at one point it could have had an atmosphere, especially considering the pictures we're seeing, and we're only allowed to see like maybe 2% of what's out there. We don't get all those pictures.
Yeah,
we get what's filtered, right?
So yeah, I would just say this: there's a big null zone in between us and them. So whatever gravity's done over there, I don't think it'll affect it unless it's close enough to the Earth. So, but I don't think that it is. What I worry more about is the frequency that it puts off. Is it going to be anything close to the Earth? because if you know anything about frequency, once you have two frequencies of the same thing, you can end up with resonance. And that would worry me more than anything else. So
I think that's how our planet, our universe works to some degree. It works on resonance. So if one planet shifts its resonance, then so will all the rest. Just like in my coil, I can't pull power out over here on one side of the coil without affecting power over here. Right?
Yeah.
It all matters.
Yeah, well, I'm getting into the thermal like you did, and I'm moving the heat around, and I found this out. It's so interesting. We're looking at another guy's Tesla coils, open ends on both sides, right?
Yeah.
So the air flows better. Now, what happens in that is you get colder in the center. We generally put it on a pedestal so it has a closed bottom to it. And it's trapping heat. So it makes the whole thing go out further, but it's a big energy loss. So I'm getting a lot of hysteresis out of it, and I don't like it. So I'm going to put it on a stand where it's opened up on the bottom and see if I can't get it to flow and cool it down. It's just an interesting way of looking at it, because as soon as I capped the top and it had more heat inside, the heat was turning to amps, which made my field stronger and pushed out more heat energy to it. And it was like, my power source is aluminum, and usually at 11 volts, it doesn't touch it at 2.5 feet. It doesn't even say hello. Now at 11 volts, I'm not only touching it, but I'm heating it up. So as soon as I change the heat in the system, it's changing how it works. So now we got to go to the reverse and open both sides and then get it to flow.
Do you realize what that is by playing with the heat? It's the unified field theory. It's what every physicist and his monkey has been looking for since the beginning of physics. They want to be able to control it, move it around, take the cold, do what they want with it, because to them, that makes them something they're not. We're all just people, man. Just because you know how to work a system doesn't make you any different than anyone else. You're no special person just because you got a patent or some thing out there. You know what I mean? Like,
isn't it entropy? Is that the right word?
So entropy can be used, but you got to watch how it flows. Entropy is always the system's way of trying to perform balance. So when you create an imbalance by spinning up a whole bunch of energy, oh, my battery is getting low. Hang on one second. You're going to plug it back in. Then, and it's got to come back down. As it's coming back down, you can capture it. Wow, I took that cap right out. Kidding, I didn't hurt it. It was running and bounced off my foot. Apologize about that. My battery was just about to die. I had to plug it in. Okay, so entropy can be used, but they don't know how to use it, because the way that most people think, and engineers have done everything they could to write those instabilities out of their systems. When you spin up any system or put a bunch of power into it, it has to go back to zero, right? That's the balance that has to be created. So, excuse me. When you're running, say, a heater, an induction heater, you put all that juice in it. As that juice is going through and it's heating up because of the resistive factor, it's got to come back to where it started to bring that voltage back to zero for balance. That's entropy. I don't let that happen. When I spin the system up and it's about to come back with entropy, I give it a path of least resistance and I capture it. That makes entropy null and void. But you need entropy to run the system. Without entropy, the system couldn't run. So it's like they're hand in hand, right? They're without one, you can't have the other.
Now, don't you just control that with your load?
Yes, but most engineers don't even think that way. They need to start. See, they reverse the system. Go ahead.
Well, so far my Tesla coil doesn't have any load on it. So I'm running ungrounded, no load.
Yeah.
I haven't got to the experiment yet where I double ground and put a load. So I'm way behind you. Okay. But
You're not, though. You're ahead of me in many different ways.
It all proves out, I guess, different ways in each system.
Right.
What I found funny is I kept thinking about your coil, right? When they're 180 out, okay, you have to have one turn on, then the next one turn on, next one turn on, next. You that's how you're getting that Tesla coil oscillation out of it. I was trying to figure that out for the longest time until I put it in my brain exactly what you were saying.
Okay. But how does one turn on after the other turns off without using transistors? Because that's how it operates. I don't need transistors to do that. All I need is one transistor and a cap.
Well, it's okay. One magnetic field will bleed into the second magnetic field.
There you go.
And it goes back and forth. Yes.
Yeah. It's like breathing.
Yes. So it'll essentially feed itself. So it's like a light bulb. This one turns on, right? And as it gets dim, the other one's turning on.
Exactly.
And then back and forth, back and forth. Yeah.
You get it. And that's what I think Tesla was doing with that line down the middle of his Tesla coil. As he was running it up, it's creating current because it's grounding. And I think that's how he was capturing all of his loads. That's why he said, I'd get it for free. Because he's not stopping the system from running. He's running the system and capturing the flow when it goes back to ground.
Yeah, but that double ground is just unbelievable in how it works. So
it's that double ground makes the circuit. You know what I mean?
Yeah. Sorry. I'm sorry, guys, if everybody's not following, but we're working on kind of Gerald's got his coil, right? And everybody's seen it. I'm working on Tesla coils, and we're pulling kind of the same experiment, probably in reverse area of each other.
He's doing it. He's doing it.
So
he's just doing it differently. There's more than one way to do it.
But when you start grounding things, just so you'll learn in your Tesla coil, if you've never run one, as soon as you put it into ground, you gain 20% more energy. That's a fact. Put the number 2 directly into the ground, you get 20% more energy. Why? It's just like putting the wire down the center of it. You're adding a lot more to the Tesla coil. I just added the earth as part of my number 2 on my Tesla coil. Okay? That's a way to look at it that's a little bit different. You go, it doesn't respond the same as wire, so you're going to get a different flow of energy coming out of it as well. It's not the same energy that you're pumping out of your regular wall socket. Now, just remember, your grounding is different from your wall socket than it is outside. So you're going to have to deal with that as well, because you're getting dirty energy coming out of your wall socket on the ground because it's already part of a loop system. You're getting clean energy out of the ground. So they work a bit differently. So you'll have to adjust your coil a little bit. I had to pound a copper rod into the ground and run my number 2 coil off of it, and you can see the difference.
When you say like dirty, you mean like the signal's cleaner, maybe, or it's easier to get the same amount of energy?
It's cleaner. It's easier to work with. There's no interference pattern in it already from the rest of the system going through your wall.
Not so
right. Okay, that's what you mean. Yeah, it's not. It's pure. It's a pure signal.
Yeah, it's like looking at 432 hertz versus 440. 440 would be like the wall. 432 would be like the ground.
Constructive versus deconstructive. Okay.
Yeah.
Gotcha.
Have you tried putting a cap to ground? So when you go from so you have 2 grounds, right? So your secondary ground, when you're actually going into the earth, come off your Tesla coil, through your center part, and then put a cap in there and go to ground and tap that cap as a load all day long.
I gotta tap that cap, baby.
Yeah, and it won't affect your system. It shouldn't.
That's
all
interesting.
Day long, man. That was one of Tesla's tricks.
Huh.
He put it in between the cap and the number 1 winding.
So the number 1 winding, that's what you use to go down the center, correct? At the end of the number 1 winding?
No.
No?
that wire is connected to nothing.
Oh, have you ever tried putting it down the center?
Well, no, I've seen people take their number 2 winding and then at the very top put it back down the center. That
Oh,
gives
yeah,
you an
okay, so
increase.
I'm getting
I-
it mixed up. Number 1's the thick one.
I just put a regular wire attached to a load down the center of the coil
So it's not attached to the Tesla coil at all.
at all.
Okay, so then your wire that you go up into the center with, go from that wire to a cap and then from that cap to the ground. Do you ground that wire out normally when you get a load?
I don't have to ground anything on the system when it goes to the load, and it pulls that energy right into that secondary coil.
Okay, so the only thing I'm trying to picture
So
on your system is where you ground to earth, a cap has to be just before the earth in your connection.
Okay, so
Okay.
how I normally ground my Tesla coil, right? I ground it on my negative of my Tesla coil. Okay, if
Yeah.
it's the Slayer exciter, if it's the ZVS circuit, okay, we ground the number 2 wire into, well, both of them, I guess you can ground the number 2 wire into the ground. Okay.
Okay.
So, or you can use the negative I use the negative on my Tesla coil when it's a Slayer exciter. Just difference.
It's
Anyway.
Yeah.
Either way, the number 2 winding put into the ground, and then on the secondary coil, I need to put another ground there. So
it goes into the earth or just
it
floating
goes in the earth, because what I'm doing is I'm making the ground the capacitor
Okay.
instead of adding the capacitor.
Okay. So now then,
Now I can loop my circuit.
as an experiment, try putting 2 capacitors just before your ground on either ground. So your first ground would have a cap, your second ground would have a cap, and see if your power output comes up. Mine did.
Interesting.
There's something that I'm going to get into that none of these physicists talk about, and there's no theory out there to, as far as I'm aware, connect to, but it has to do with your bubble and where you put your positive, your negative, where your heat goes, and where the spin is created. It all matters. The geometry doesn't stop at the coil. It stops at the edge of the field, at the boundary layer. Right?
Okay. Now I have experience with that one.
Yeah. So and at the boundary layer, there's 2 points. There's a positive and a negative. They have to be there. They're internodal points of spin. So think of it like a positive, a negative, and then you have your center. Right? We don't think of it that way because of the way we do our coils. But there has to be a positive. There has to be a negative. And I'll get it. I might be confusing you, and I'll stop right now.
No, you're not.
I'll explain something. Remember the experiment with my daughter that I told you about?
Yeah.
Okay, well, that has to do with that. One battery was on one side of the room, and the other battery was on the other side of the room. Do you get what I'm saying now?
Yeah, I got it.
Okay.
I get it.
Yep.
Not because
What's that?
No. It goes to another experiment I was doing.
Yep.
So.
There's more to this than meets the eye, and because the physicists haven't been doing the experiments, like I'm telling you, that water experiment, it took me 8 different tests just to find it the first time after I had everything working, if that makes sense. Right? So it's not like you're going to go at this and have the theory and all of a sudden you're going to start putting stuff together and there it is. No, man, there's like a million tests you have to do to understand how these principles are put into play in engineering. But we're there.
Yeah.
If there was people out there that wanted to invest in this tech, and I'm not saying that's what we should do. I'm just saying we are at the forefront of this because we're building the devices. We're doing the experiments. Not this stuff that they're doing up at with little machines and watching them go micrometers and calling it amazing work. I want to see a foot, man. I want to see like 100 pounds levitating above my freaking desk. You want to impress me. Otherwise, it's just all this for your academic paper.
You know what happens after you charge the ground as a capacitor, Gerald?
Yep.
So anti-gravity is not really that difficult after that. It's pretty much over. That's the ball game. Once you can figure out what you're doing, it's pretty much over. Because
electrospinning. It was referred to as electrospinning. When you make the ground negative and it's positive up above, you have that push, right? And if you're the one that's positive and you're standing on the ground, you get that push. Guess who goes?
Yeah.
Just saying. You know,
Well,
there's so much to this.
I think it has to do just with charges. Okay, so I don't think that it's necessarily positive or negative, but which field is stronger and which one's weaker. So
Yes.
then you have to flip one field around. So
Okay.
as
but
you're pulled down, you have to flip it so it thinks it wants to attract up as it repels the bottom. It's both. It's like an elevator.
But you can't get to that position unless you use positive and negative.
Well, no, I'm not saying that. I'm just saying, but once it goes into the earth works on charges. Okay.
Yeah.
It's not necessarily positive or negative. So you have to see your positive negatives of charges as a weaker charge and then a higher charge. So your positive is always your higher charge and your negative is always your weaker charge, right?
See, now I've always seen that as your higher charge being your positive charge because it always goes from high to low on entropy, right? So I've always seen it that way. So when I'm explaining it, I know exactly what you're saying. I'm talking about charge, but in the sense where it's, you know what I mean? Positive, negative. I don't know.
No, I get it. It's just another layer onto it, but it has to be there because when you start pulling experiments, like you want to see like heavy experiments on your scale, right? Because people think that's anti-gravity and it's just not, but okay, I'll do it for fun one day and I'll show you. Yeah. Because as soon as I put my little saucer thing on there and I'm just charging paper, this is literally how dumb it is. I am using paper in the dielectric and saturating it, and I can pull a tremendous amount of force to one side. Now, I can pull 2 pounds on the scale, and I guarantee you say, oh my God, you got anti-gravity. But I don't. I just have pressure. Now, the interesting thing about the pressure is, if the pressure is turned around and it goes up, will I then remove weight from anything that I do to it? So if I can pull 2 pounds of pressure and make a craft that's 2 pounds, will any bit of movement move it? Could I basically slip a PC fan in there and get it to move?
Maybe.
That's the interesting part.
See, if you're charged, yeah. See, and that's what I thought too. I thought when it comes to anti-gravity, you're not going to like jump jet and go. You're going to make it literally float, and you're going to need a secondary system to make it go. Whether it be fans or a secondary field to push to create a secondary bubble, then a third, then a fourth, and you're building. But that doesn't mean you can pop any of those bubbles. It doesn't work like that.
But if we're inside the bubble and all we're doing is moving our energy inside the bubble, okay? We're between two fields and all we're doing is moving that between the two fields. It's instantaneous.
Yeah.
It's because you're saturated your craft. So once it's saturated, it now acts just like the environment itself, not the ground, not the top, the environment itself. And now it actually has no resistance because it can't tell the difference.
Okay. And I get that. That's anti-gravity. Okay. My point is when it's buoyant, because it's only going to sit at its highest energy level in comparison to the lowest energy level of its buoyancy in comparison to the Earth. Do you know what I mean?
Mm-hmm.
Okay, so as it's sitting above the Earth and it's kind of floating there and bobbing up and down, because we have different potentials as we go higher in our atmosphere, The only way to make that thing go up, in my mind, would be to change the potential so that the potential difference squeezes it like a grape through your fingers when you pop it out. You know what I mean? And then as soon as it's further up, your potential, say, I think it's 100 volts every meter. So let's say you're 1,000 meters. It's what, 30,000 volts at that point? So as when you first become buoyant and then you turn your potential difference up and you shoot up, now your potential difference in your sphere is 30,000 volts compared to the ground. It's just going to stop there. It's not going to move because now its equilibrium has been achieved through entropy at 30,000 volts and no more and no less, because it's higher than the potential ground below it, and it can't go higher than the potential above it. So now it's locked in, and that's what the scientific community calls flux pinning. But essentially, that's what it's doing. You know what I mean? That's my thought. I mean, I could be wrong.
No, it's always interesting. I see it one way, you see another. We're all good. We'll try them both.
Damn straight. Heck, maybe we're both right.
Yeah.
There's
Maybe
more than one
there's
way.
two different things to use, because once you create a field around your craft, once you get out to space, you potentially have a field around it. And the crazy thing is that depending on how you do your high voltage out there, you're going to create ozone. If you trap the ozone in a Tesla coil field, then you can create O3. Now you can break that O3 down to O2, okay, and then combine one of the oxygens with something else. So it's just interesting.
I think space would have a different mechanism, though. Like it would work off the same principle, but a different flow of energy. Like in our atmosphere between ground and the outer atmosphere, I think that's a matter of potential volt difference. But whereas when you get into space, that's like a scalar plasmatic ion drive all mixed in one.
No, I don't disagree with that, but all you have to do is start the engine out in space, because you'll keep going at that same speed after you turn it on. And then you basically just have to have good enough brakes.
Or a reverse field.
So if you're creating your own gravity inside the craft, which is what we're going to end up doing by creating the field, then you can repel against the planet as you're coming up to it and slow down that way without exhausting any source of energy.
Absolutely. I agree with that 100%.
So, Ben, you got a picture to show real quick?
Yeah, so the Society of High Sciences sent me a image of Mars, and it has a caption. It says, yes, the structure in your image having a similar size to the pyramid of Djoser, which is considered the oldest pyramid in Egypt, built around 2670 BCE, is quite an intriguing comparison. I think I'm pronouncing this incorrectly. The Djoser pyramid, with a base length of around 411 feet, 125 meters, is fairly close to the approximate 393.6 feet in length of the structure you measured. So 393 versus 411, and that's an approximation here. So pretty interesting. I don't know. Pretty interesting.
That's awesome.
Yeah. Thank you for sharing this with us, Society. We really appreciate that.
Absolutely. That's awesome.
So, yeah. Anyway, I just wanted to get back to the coils for a minute, because once I pull the double grounding, and if I can get it to act as a capacitor, it'll change the game. It's because, and here's the reason why I think I'm not going to have as many issues as you may think. As soon as you plug the wire into the ground,
Yeah.
and put it in your number 2 coil, you pick up 20% of energy.
Yeah.
As soon as I put another coil, even if it's a different frequency, and I put the wire into the ground, I have a potential to pick up 20%. The only thing that I need to do between those 2 points is make sure that the ground's moist. That's pretty much it. If I could do it through water, and I have the minerals in my ground to match what I would need to transfer it through the water in the ground, and because I'm using a French drain, okay, which is basically just dirt, a bunch of rock, and then it's sand on the top. That's pretty much what I have.
Yeah.
So if I go in there after a rain and I put both coils in, I should be able to pick it up just with the water level alone that's inside of it. And again, we're talking like a bare rod all the way down. No covering.
Okay, well, I'm not sure about this, but I think the whole purpose behind putting a capacitor to ground on both grounds was tuning the ground capacitance.
Oh, really?
Yeah. Yeah, where you didn't need water.
Okay.
That was the purpose. I could be wrong, but from my understanding, from what I've read, that's the purpose behind it. I'm still playing with that right now. So, and like you, I have a pipe that goes directly into the ground and it's rock and all that other stuff. That's where the water accumulates from the house. I'm going to change it.
So,
yeah.
Check this out. Just so we're aware. The grounding goes to your house, right? That goes into everything. So when I put my gravity flyer on the ground, in my garage, on the concrete, it's grounded. Mm-hmm. When I connect my wire from my Tesla coil to my ground, I have now created a circuit in between the two. So I know that for sure. Here's why. I pick up an additional 30% to 40% energy in my gravity flyer. It automatically picks up energy and starts filling my fields the right way. Okay? It automatically does it. There's no getting around it. If you have everything on with too much power, it overpowers the system and sparks it out. If you don't, okay, and you have it set to a low enough, and this is what drives me crazy. Everybody wants a ton of power in this thing. If you overdo it in the beginning, it'll kill the field and you start over. But if you have it low enough and you've saturated the center, and then you start driving it in there, okay, this thing starts to tweak a little bit. It starts to pull, okay? It's starting to lose its ability to stay on the ground. Now, could that be pushed from the ground, or could it just be lifting? And I can't tell you the answer to that. I can tell you that it's working. So just so we understand each other, that's why you do this, and you have to have it grounded on the ground, because concrete actually does make a good ability to pull energy from it.
Yeah. The more and more we talk about this, the more I believe that those two capacitors to ground were for tuning the ground. Because if you tuned your ground, you can tune your Tesla coil, I wonder if that's how Tesla found anti-gravity to begin with. Because remember, there's all kinds of chapters in his work that are missing. He used to work with Otis T. Carr. And Otis T. Carr, well, we all know about the Neutron. I wonder where Otis came up with that. Know what I mean? So where was it that Tesla first started to see this anomaly? I have a feeling it had to do with tuning the ground.
Yeah, in Colorado.
Yep. And I think that's when he started to get into anti-gravity and got into geometry in a different sense that he was already. Right? So
I 100% agree. That's why I'm doing the tests that I'm doing, because I keep telling people there's more energy in there, right? And I've shown it already on my channel where I pick up the energy. And I pointed out 100 times, hey, this is the point right here. You see it as picking up the energy. You see it, just the sparking goes crazy on this thing. And it shows, hey, we got a ton of energy being picked up here out of nowhere, right? Now I know where it's coming from. But in order to get you to understand the next part, I have to do the Tesla coil, You know what I mean? Show exactly how it works so that we can all understand it together.
Yep.
Because it'll be one of those black hole mysteries if you don't.
So I gotta say this, and I've told a few people in the scientific community this, but I don't know if it caught on. If you're trying to build a bubble, sparks kill the bubble.
Yeah.
Yep. Absolutely. The minute you get a snap, the bubble's gone.
Yep.
Yep. I wonder if that has to do with a quick snap of sound, or is it just the spark? I think it's both.
It uses all the voltage in the system. It's a short. It shorts it out.
Okay, and I would agree with you 100% on that, except for one thing. I've done a few experiments where I've created bubbles, and you can feel it in the air, right? Like my ears have popped.
Yeah.
And in the beginning, I didn't know how to break these bubbles because you can't just shut off your system and then it's broken. You shut off your system, it's got to drain through the ground. You can break it quick through a spark gap. I found that out through reading and then testing. But there was another way I broke the bubble.
Okay.
And it was by clapping really, really loud, because I can clap loud. I have big hands, right?
Yeah.
So I clapped really loud, and it sounded like a crack, like thunder. Not that I can do it, but you know what I mean, right? And the bubble disappeared. Like I didn't feel it anymore. My ears were like I was walking up a mountain. That's how it feels. The pressure builds when your bubble's building. It feels like you're walking to a higher elevation. You literally got to hold your nose and blow to pop your ears.
So you broke the resonance of the system with sound.
Yeah, by doing this here, hold your ears. It's pretty loud, right?
Yeah. All right, I'm gonna try that. That's interesting.
So try it. Let me know. Hopefully I didn't misconstrue something or got it wrong. Prove me right, prove me wrong. It's just information in the end, right? So,
well, that would truly suck for anti-gravity. One thunderstorm and you're screwed. So
maybe I am wrong, but maybe okay, so let me reiterate just one more. There's a detail that should come out on that. That only occurs once you shut the system off. You can't pop the bubble. Once the bubble's been built, I don't think a spark blows it. It's in the building process of it. Do you know what I mean? Like, okay, so go ahead.
No, I'm agreeing with you. It takes 10 minutes to build it.
Yeah, so it's like as it's building, you could break it with a spark gap. But if you don't, and it's building and it gets to that point where it's complete and your system's still running, your spark gap ain't going to do shit. And no spark or loud cap ain't going to do nothing. But the second you shut your system off and the oscillations have ceased, a big bang or a crack from a spark gap will shut it down instantly.
Okay, so check this out. And this is one of the crazier things. When you actually achieve the point where it builds up the energy, right?
Yeah.
It tends to, if it goes too fast back into the ground, create a little bit of a rumble. Okay?
Yeah.
And depending on how much energy you put into this. So if you're just connected to like a pipe on the wall, you're going to get a bit of a rumble on your pipe. Okay? You know what I mean? If it's connected to something else, you're going to get a little, because you're discharging it so fast. And if you can understand that, if you're dumping a ton of energy into it right away and then dumping it out. And sometimes when you build these bubbles all the way the size of your garage on accident and blow out half the stuff in your garage, then there's a lot of energy there. When you don't know how to control it the first time when you do it, and things by your garage door lighting up, but you're at the other side of your garage 20 feet away, it tends to tell you something.
It does.
You got way too much going through there. And it took me a while. I had to reverse the field. Okay. And I always talk about this. I had to reverse the field in order to understand it because I couldn't get it why things were doing this way. But when you run your gravity flyer and you put the plate, and that's usually your Tesla coil, right? But I put the high voltage on it, and then I put the Tesla coil just to the top plate, right through my center of my Tesla coil, never attaching it to anything, to the bottom plate. Now my Tesla coil pushes the high voltage or the static field or scalar field, pushes it completely out. So it'll run through your garage super fast, okay?
Yeah.
And then you got a mess going on, and everything starts to go out. It's done. Yeah. You pretty much have dead electronics everywhere.
Yeah.
And then when you put the Tesla coil field to the center plate and you run the voltage back on the top and bottom, it's holding it in. And the only way to know that is to run it in reverse.
That's interesting.
So
I know that when there's another way of draining the bubble by, because you have to use a high frequency, right? You can't use 7.83. So if your bubble's like huge, and let's say you're feeling some adverse effect, switch the frequency to 7.83 to resonate with the earth, instantly it drains. And you're
check this out. My Tesla coil resonates at 300 kilohertz. My gravity flyer resonates at 25 megahertz. Okay. So just so you understand this, but then when I put my wire next to my Tesla coil, I get 25 megahertz. My Tesla coil doesn't go to 25 megahertz normally. Now, I pick up 3 frequencies in my gravity flyer. All of them are the same. Now, why do they get to the same? And it has to do with poor wiring and beat frequency.
Yeah,
it saturates all the lines and puts the frequency into the lines. And you wouldn't know that unless you worked with high voltage lines and the non-high voltage line. It's a saturation of the beat frequency. It all changes. So if you want to know how to get this thing way up there, I've already figured it out.
Yeah, everything's part of the circuit, man. Every wire, every length of wire, every piece of solder, every screw, it all matters when you're dealing with this stuff.
Now that's even before I amplified it. Okay. You see, what people don't understand is the piezo buzzer itself will amplify the actual amount that's in there. So if it's 25, it's in the megahertz, it immediately jumps over 100 megahertz easily. And that's on a bad push. Okay. When I push that button, that ultrasound, it's making that whole top of the thing. So you see it on your oscilloscope, right? It goes just like this. It goes boom, just like that. And I have it recorded and everything, and it's a trip, okay, to see what it's doing. But it kind of tells you what's going on. If you're saying I need a terahertz to lift it, well, I might just have a terahertz, okay? It may not be good for me to sit in the room with it when I do it. I may need a special helmet for my head and my you-know-what. You know what I mean? So
I don't
give me some space pants.
I don't think it needs a terahertz to lift. I could be wrong, but I don't think so.
No, I honest to God, man, I don't think it needs that much either. I just think that it's an interesting fact of how it works, and it could just be that it's turned up too high, and it makes a dinging sound, so it will actually push the metal on it. Okay, so what I did was, in order for it to not push the metal, because that's kind of crazy, right? You got a little piezo buzzer, and it's pushing the metal of your gravity flyer in the center.
That's not pushing it. Yeah, go ahead.
Yeah. So I just lightened it. I just put in less voltage in it. So because it's picking up the energy of the actual craft is what it's doing. Because the gravity flyer's Tesla coil is connected to the entire thing. You know what I mean? So now I just turned it down. And now it's like hitting a diaphragm, just like this. That's all that I'm doing. That's all that I wanted to do. As soon as you get to the point where it's tinking, you're in trouble. You're off the mark. You're out of your octave. Never get back, and you're done.
Yeah, you know, when I bought that scope, I kind of started watching all my resonant frequencies on the scope because I could see my LED lights. They glow super bright when I'm in resonance. And on the scope, it just totally takes over everything. I had to go 10 times resistance just to see it. And like you, it's almost like a switch. It's like off resonance, bang, right? It's instant. So, yeah, I think it's like turning a channel on a TV rather than making sure you have enough power to do it.
Oh, better yet, more like that AM radio.
Yeah.
You're out of it. You're listening to the wrong station, and then you get right on it, and it's perfect.
There. I agree 100%. 100%.
By the way, I do now understand why you use the AM radio to find the point of static. Okay.
Yeah, do you?
Yeah, I get it.
Nice. Yeah, you can hear it. It's almost like a meter all on its own.
Yeah.
Yeah.
For those of you who don't know what we're talking about, we're looking for the actual bubble and where to outline that, right? And we're trying to see, okay, where's this thing we think it ends, and where does it actually end? So I usually use a little, 4-foot light bulb, and I'm just checking it and see where, as far as it comes out, where the energy is.
Yeah.
But with the radio, it's different. Okay. There's different distances in it, and what it is, you're picking up a crackling sound in your radio, and you'll start to hear it like fuzz, kind of like a white noise, and it picks up right there when the fields are met together. It starts to pick it up right there really good. And the cool thing I did was I took the Tesla coil and I took my high voltage, right? And I just dial them one and the other until I made sure they met. Okay?
Yep.
And you can nail it perfect.
Yep. Radio's a beautiful thing, right? Yeah, you can literally, when you hear the resonance in your radio, like for you, it's static because it's a Tesla coil. But for me, I hear a tone, and the different frequency of what I'm using in my coil will define the tone I'm hearing in the AM radio. And I can hear it get real loud when I get close to the node, or it gets real quiet, but I can still lightly hear it, right? So it's literally like a resonant meter. It's awesome. Yeah. So everybody, grab an AM radio when you're doing this kind of testing and tech. You'll find more than you think.
And by the way, guys, if you want a Slayer exciter circuit, just look on my channel. I build one, man, that's like bulletproof for anything under 40 volts. You're not blowing that transistor up. Okay. This thing is just amazing to work with. You're not having them fry every 2 seconds. It literally lasts you like forever, and it doesn't get hot. But just watch it. If you do start putting things down the coil and you let it spark, okay, that's when it gets hot. That's when you have to worry. But as soon as you put it down, there's no spark. That's it. And by the way, it's pulling the energy into the wire. It's not pushing it out. A lot of people think it's sparking out when you put it down the center.
Yeah. It's
pulling it in. It's like Sean's grounding on his.
Yeah. He needs the. Yeah. Wow. That's cool.
It's a bit different, isn't it?
Yep, it is.
The unique feature is once the rod is down the entire thing, there's no sparking that goes on whatsoever. Not at all. It's all that nonsense stops. It allows it because it's not sharp at all. It allows it to just pull the energy into it. When it's sharp, it breaks it.
Use it as a load then, eh? Or you could.
Yeah.
Yeah.
Well, that's what I'm trying to say. I was using my rodent coil as load.
Oh yeah, right. That was a good video.
Yeah.
Yeah.
So like I said, I wanted to ground my load, which is the rodent coil, and then ground my Tesla coil and do my double ground. So it'll kind of mimic the gravity flyer so that people can understand it, I guess, a little better. Or 2 Tesla coils will do it.
Yeah.
But now, if I took, oh man, what's the name of that place? I just had it in my head. It's not the word art. It's a real short word. It's It's a place that has a bunch of water on it, and it's got a bunch of towers, and it's an ancient structure.
Not Göbekli Tepe.
No. I forget what it is. Anyway, there's a center pillar that goes in the center of it, right? And then there's 4 corners on it, and then there's 8 all the way around it. Okay. And I always said if I took the center and put my Tesla coil there, drove it into the ground, and if I put water in between each tower, it came over. The whole thing would be lit up like daylight.
Makes one wonder. It makes one wonder if that's what they used to use to create a force field around their city.
Anchor Watt.
Yeah, Anchor Watt. There you go. So you have pillars all around your city. They're all connected with water, and you have this tech. You turn it on. Those pillars act as nodal points, completing the field. You now have a force field for your city.
But as soon as you put it into the ground, you no longer have to use the radiant energy coming out of it. Now we're pulling it down, so I can turn the Tesla coil way down in this, you know what I mean, on the center one.
Yeah.
Because now it's a cleaner source to everything.
Yeah, that's true.
So the radiant energy will create heat if you wanted to turn it to heat the earth in case it got really cold outside, the area around it.
Yeah.
But then again, you don't want radiant energy all the time. You know what I mean? So you want to put it through the ground to heat it, and you might just heat the ground. I don't know if it gets hot. I think it usually gets colder when I put it in there. When I figure out how to turn it around.
You'd have to test to see. Because when you're playing with temperature and moving that stuff around, you have to know where it goes. It's got to go somewhere. I didn't think so, but it does. It's got to go somewhere. Hi, Lulu. Oh, and Mike, we didn't get a chance to say hi earlier. He said, yo.
Ian's out there. See him as well.
Ian's out there. Yeah, everybody's in the comment.
Yeah.
We have such an awesome comment section. I love it.
Yeah. So I'm excited about the testing because we're getting into that next level now where each time you put out a video, I'm putting out a video, and I'm trying to stay in line with where you are so that we can
coordinate if you want. I don't mind. I'm not trying to, but it comes and it's like, okay, I got to do it. Right.
Joel's the same way.
Yeah.
And I'm not far behind. I'll be catching up real soon.
Well, Ben's catching up because of that circuit that he built. He got that new circuit in there. Works for his system really well.
Oh,
yeah, there's a couple. Yeah, I'm sorry. I didn't mean to interrupt.
No, go ahead.
I was just going to say, there's a couple of clips I wanted to show you in my last video. I didn't want to show the whole thing, but because I had a couple of questions for you.
No, feel free. Pull it
let
up.
me finish eating. Give me like 5 minutes.
Okay. Did you see my recent video?
I saw a bunch of them. I think I did. Hang on. We'll just pull it up.
I tried to watch all of them.
The recent video was 2 Vortex coils hanging from string.
Yep.
And and a pickup coil. Excuse me, hanging from string as well.
I don't know if I've seen that one. Let's take a look.
Let's just play it.
I've seen this one.
Okay, go for it.
Check this out. This experiment is meant to show you induction without it actually being too close to the coils. These are Vortex coils. This experiment's going to be done just a little differently than most. So there's our power supply, that 12-volt battery. This is our regular modified Joule fief circuit. So this transistor here is going to pulse the primary of this Vortex coil. And this transistor is going to pulse the secondary of this Vortex coil. We're going to pulse it at 1,000 hertz, 3% duty cycle, 20 volts per pulse. This meter goes to the full wave bridge rectifier of that pickup coil, which is 120 wraps of a ferrite core. Now, technically, we shouldn't get really anything out of it, but let's hit it and see. All right, turning on the primary, we're pulsing the primary in 3, 2, 1. We have 102 volts on our meter, 1 neon running from our full wave bridge rectifier. Remember, it's not touching, ladies and gentlemen. So let's see if there's an explosive effect by turning on the secondary. In 3, 2, 1. Our secondary is on. We reached 120 volts, and now we're down to 115. And both neons are running, all coming from that 12-volt battery. And it's not even close. All right, ladies and gentlemen.
You're not really
Feel
pulling
free
it
to explain
anywhere.
in the comment section. And I hope you all have a really great day.
Yeah, you know what? It's not even touching the coils. I've seen a lot of videos on YouTube about using ferrite core pickup coils, but they have to be next to the coil or they have to be in the open core. Mine's not even touching them, not even in the open core. Do you want to know what I was showing?
What are you showing? Because I'm kind of confused. It's not like it's.
Somebody even put in a comment on the bottom of the video in the comment section, and I thank him for it. Awesome comment. He's like, I don't know what you're trying to do here. Like, I don't get it. I think it failed. But nice work. Thank you for that. I'll tell you. So the two coils, one of them was pushing a vortex out, and it was attaching to the ferrite core. Then I pushed the other one out, and it attached to the ferrite core. But it wasn't, the ferrite core wasn't sitting in the center. I just got to stop doing that. Wasn't sitting in the center of the open core. That's how I normally pick up the energy. Like you take that line and you put it through the center of the Tesla coil. It's got to be in the inside, right? Mine wasn't. It was sitting on the outside of both. Both of them were sitting on the outside of that ferrite. It should not have picked up voltage at all. Do you know any solenoid or any coil out there that has done that?
No.
And I'll fully admit that I'm wrong if there is, but I think that's the only experiment ever out there on YouTube that shows that.
But you pick it up with your other coils when you put things on the outside, when you put the pickups on the outside of the coil.
Yeah.
Okay.
But this is not on the outside of the coil. This is above both coils. Think about that. It's like this, right? Say this is the surface of my coil. The core is sitting here. It's sitting above it. It's not even interacting with it. I just put it sideways, right? So because it's not interacting, this shouldn't have any power in it. If it was in the open core, I get that. It's interacting with the coil. It's induction, right? If it's on the side of it, that's induction. But what is it when it's sitting on the outside of the top of the coil? And then you have another coil sitting over here, and it's on the top of that one.
No, I know what it is. You pulled the dielectric. No. You pulled a dielectric in there.
I compressed the dielectric and compressed charge density into the center where that ferrite.
That's right.
And I pulled the energy out.
Saturated your core. That's what
Kudos
you're
for
doing.
using snack packs, by the way. I love them.
Right? Visual. Hey, butterscotch.
That's my favorite one.
Mine too. So essentially, Gerald, make the finger in the hole sign for it. So essentially, you know what I'm saying? But yeah, that when it sits on the edge, it shouldn't pick up any energy. Like I've never seen a solenoid coil do that, or a toroid coil, or no offense, Ben, a rodent coil. I've never seen that field get pushed out to the point where it's compressed to the point of saturation and something that has it's not even touching them. Like
yeah. Well, the rodent coil has its limitations, you know, and I'll describe more in detail about them, you know, as I show you the video. But yeah, that it's I'm starting to see why.
I'm not dissing on the rodent coil. I'm just trying to point out the fact that I've never seen a coil or a system do that and compress its charge when it's not even touching it.
Well, we've always had the theory since day one that different geometric patterns for these coils will have different effects, you know? And I've always been a firm believer in that.
Okay, so you know how the vortex, created and it comes down to a point.
Mm.
There's another vortex that's created that comes up to a point. My coils can do, depending on how you wire the 4 wires that come off of it by fire loom. You can wire them in series. You can put them in parallel. You can wire them individually. There's a bunch you can do to it. I can push the vortex out from the coil and hold it at a certain distance. So what I did was I pushed the vortex out of the coil, and then I took a second coil and I pushed the vortex out in that coil, and they met in the center right where that ferrite core was. And that's how I was able to get the voltage out. Bail on a cat's part.
Okay, hold on. I'm looking up a video. Ben, do you have your stuff ready?
Yeah, I'm gonna show you guys just 2 clips from the video I just released on my YouTube. If you guys aren't aware, I'm on Beneficence TV on YouTube. You'll see it on my tag. If you type it in the search, though, you have to separate the Beneficence from, you put a space in between TV or it won't pop up. So we got, just share the screen.
By the way, I wanted to say hi to Mike Faraday real quick. He was out there.
Oh, hey, Mike Faraday.
Hey, what's up, Mike?
And Mike does. Yo.
So I have a bit of a transistor mystery, right? A transistor paradox here.
Okay.
And I'm hoping that, asking you guys what's going on, I might be able to get an answer. So I am I am using I am using the transistor that you recommended, and then you had it mislabeled. So I'm using the E13009, which still works really good.
Yeah,
but it's not the exact one. You said what?
You know what? It's good, but it's not as fast as the MJE and slightly less amps. But other than that, it's a pretty good transistor.
So I think it is as you'll see in a second, I think it's the route that I'm going to take if I develop the Joule Thief any further, just because it seems to be a little bit more finely tuned. I'm not sure what's going on here, because it has, like I said, there's sort of a paradox you'll see in the video, and I'll describe it. But essentially, I'm using an E13009 and then swapping it out for the MJL21194G.
I seen that. You can see the fan. You can actually hear the tone of the fan slow down.
Yeah, and it's interesting though, because the transistor that was working, it seemed to be working a little bit more efficiently. Like the amperage went down when the fan went up, right? It was maintaining the light. The light didn't dim or get any brighter really, but it seemed to be maintaining and be more efficiently, operating more efficiently off of the slightly lower amperage on the input. You'll see it dropped slightly, right? But when I unplugged the load from that one that's working more efficiently, the neon lamp isn't as bright as the other transistor. It's very weird. Like you would think when you unplug the load, the neon light would just be really bright, right?
No, because you have, okay, how do I put this? So your system has less resistance than normal. And when you put your load on, you're adding resistance to it and controlling your saturation.
So it's weird because the other one seems to be shining very, very bright.
Yeah, I've seen that too. That's the MJE, right?
Yeah, so this is the little tiny one is the E13009.
Okay.
And then the bigger one is the MJL.
Right.
So you see it's 8.7 and 0.3. And then I swap it out. And this one seems to be pink though. So that's the thing that struck me as the most odd. It seemed to be more pink, and the other one seemed to be more orange. Maybe there's just not enough power in the other one to see the pink if it's there. You know what I mean?
Yeah, that's a higher charge density by far. You're close to ball lightning at that point.
Yeah, it seems like it's right on the edge, and you could tell
Literally.
like you could tell because sometimes the potential when I had the potentiometer hooked up, because I have it swapped out for resistors now, but when I have the potentiometer hooked up, it's very sensitive. So at a certain we touch it a certain way, and it kind of like goes pink, and then that de-escalates as the frequency kind of hones in or whatever, and you'll see the waveform kind of like go from really really big to small. But yeah, it goes straight from pink to orange. So
Nice.
Usually the reason why your neon goes pink is because you have a higher charge density, and that's due to a faster rise and fall time on your transistor. In other words, like a faster snap, a faster pulse rate.
right, so
That's
you have
why
to have the high switch rate, right?
Yeah, that's why the MJE is like amazing. It's a very very fast rise time and fast fall time.
So do you think
awesome.
would you recommend that I upgrade to the MJ E version?
You know what? It couldn't hurt. Your charge density is definitely better with the E13009.
Yeah.
But I bought those, and then I bought the MJEs again,
Mhm.
and the MJEs are just insane. That was the minute I turned it on, it had ball lightning.
Yeah, but you have a you have a huge heat sink on there. Do you think I need something that big, or you think because this isn't
No, that's
producing
only.
power?
Yeah. You know what? The only reason why the heat sink's on there is to hold the transistor down. I don't want to. I'm not gonna lie. I was having a hard time attaching it to the plastic, right? So I
Yeah.
just
Well, that's
attached
actually
it to
really
the heat sink.
yeah.
Nice.
I'll put a camera infrared on it next time I'm doing a test. You'll see how cold it is. I don't even use it. It's not for that.
Hmm.
Yeah. If I had a bracket that was wood, I'd put that there.
Huh?
Yeah. Or plastic. But it would have to be different than the acrylic.
Yeah, you see that the color change.
Yeah.
It's really cool. You'll see it again. I thought this was a really cool shot. It was hard to get though, because I was trying to turn the potentiometer with one hand and hold the camera with the other.
See, right there when it goes purple, it's so close, but ball lightning isn't just a color. You'll see it when you're looking at your neon, it almost seems like it's blinking. Because what's happening is between the two posts, it's arcing, but it's arcing in a sphere form, and it's literally spinning. Like you'll notice you're close, but
yeah, it's very close. But I think I just need to find the right resistance.
So you guys see purple there? Because I never saw the purple. I saw the orange and the red.
It's a deep red. It's on the border of being purple. When you hit purple, that's when it starts to go to ball lightning. That's why I mean he's close, right? Yeah. Charge density is pretty high. There was was there something else you wanted to ask me about it, Ben?
No, that actually explains what's going on.
Okay. You're close, dude. You're there. You just need to give it that extra.
Well, yeah, I think I just need more power and more power into the system. But I need what I need to do is order. I have 2 amp fuses. I need to order a 1 amp fuse because these I input one on here just as some kind of safety and buy a whole bag of them, so I can blow them if I need to.
I hear you.
I've gone through 2 transistors already, and I only have 1 left, I think, of this one.
I've gone through about 200. Fuses don't work for me. Sorry.
So there was one other clip I wanted to show. I got the reference circuit and the normal circuit, the coil circuit, working to demonstrate the weird thing that's going on with my coil that I haven't seen in anybody else's coil. And I'm trying to, figure out what's going on. But the only real way is to figure out is just to try to replicate it, and to try to do exactly what I did. And if anybody is interested, we have to get the frame of the coils, the coil frame, the exact same size. And we also have to use the exact same gauge of wire that I used, which was 23 gauge. and you'll be running it 24 times, but you'll be only hooking up 22 wires. So that's how I have it hooked up right now. It's only 22, but there's still that 2 extra wires you have to keep in there in case they're doing something. I don't know, you know? So, yeah, so keep that in mind if you're trying to recreate this coil. I want to try to make some and give them to, you know, different people like you guys to test, but that might be further down the road. So this is what's going on with the coil, though, that's different. So I don't have it hooked up as the open circuit. I don't have it hooked up as the Nunez method, right? It's just hooked up as, you know, induction, where I have channel A and channel B. They're not connected. Channel B is the output. Channel A is the input. And I have that hooked up to the left channel of the output of the stereo amp.
I'm listening. I got to grab a cat.
No, you're good. And then I have the reference circuit hooked up to the right channel, you know, and the same amount of energy is coming out. And you'll see that when the system is in resonance, it actually powers the coil circuit way better. And the reference circuit completely kind of just shuts down almost because, you know, it seems to be amplifying the energy a little bit.
Okay, real quick before you show your next video, Ben, I need circuits from both of you. Okay.
Oh, I keep forgetting to send that to you. I'm so sorry, Nathan.
The quickest thing you can do to write it down and get it to me, just like put it on my email, because what I have to do is be able to transfer it, look at it, and see where the energy flow goes on each one of them, so that, you know what I mean, we can all enjoy it, because everybody's asking in the chat constantly. And I know on the Wednesday show, if I just showed all the schematics, you know what I mean, for like, you know, a couple circuits for everybody, I think everybody would be thrilled to death with that.
I wrote myself.
I'll get that for you.
I sent it to you for tomorrow.
Okay, thank you.
Yeah, no problem. Sorry, everybody out there.
No, it's okay. This is a mini stereo amp board. It is an AB class amp.
Okay.
And I basically got it because I wanted a smaller version of the Insignia I was using to try to, you know, minimize the power consumption that it uses, but replicate the same experiment on a smaller scale. So it works. And I don't know why my coil works like this, but it's baffling me. Which is outputting 2 channels. One channel is going to the Rodin coil via the red and black wire in an input channel to the coil, and the output channel to the coil is the green and yellow wire going to this beautiful circuit right here with this rectified DC fan, 3 to 9 volt, and 3 LEDs with a 2K ohm resistor. Now on the opposite side, we have another channel going out, putting in the same amount of power, right? Same exact components, 3 LED, a 2K ohm resistor, rectifier, 3 to 9 volt DC fan. Now, check this out. We are getting some spin on the fan. The lights are lighting up a little bit. Doesn't look like there's much of a difference in brightness or intensity. Maybe a little bit duller on the coil side, as expected, because there's a lot of resistance in the coil. So we're at 60 hertz. Now watch this. Change it to 1000 hertz. It's resonance. And look at that. Immediately, we get the fan spinning, lights brighting up, shining brighter, and the fan stops. And this gets a little dimmer. Interesting, right? Very interesting. Now I have the probe connected to the I'm gonna need your guys' help because I wasn't able to get a signal there. LED, but it is floating, and I don't think we're picking up a signal there. So I'll try to get that signal in the next video. But as you can see, it's a clear visual that it's producing a little bit extra energy. Now watch this. Go
so hold on, Ben.
60 hertz, what's coming out of the wall?
Which one's your circuit that goes in your first circuit, and then which one's the second one, the load?
Yeah, you put your probe in the wrong hole there, Ben.
Is that what it is? Yeah, the probe is on the coil circuit. It's on I believe the cathode. Is it the cathode or the anode of the LED?
So this circuit is which one?
Oh, this is my own custom circuit. So it's basically
No. What side are we looking at? Which one's the?
oh, this is the coil right here, the coil circuit.
So this is where you first put in your power, or it's the receiving part?
This is the receiving part. So the coil's already the energy's already through the coil at this point, and it's hitting the coil circuit.
So the one on the right was the one that you said the energy went up in it, and this one went dead.
No. Yeah, the one on the right. No, I'm sorry. The one on the left went dead. The one on the left is the reference circuit that's not hooked up to the coil. That one. So this one is the one that's not hooked up to the coil. That's the reference.
Okay.
The fan stops, and this gets a little dimmer.
Okay, just so we're aware, when you pull 1,000 hertz, okay, and you go up in the hertz level, the amps go down.
I understand that, but when I measured it with the multimeters in the previous videos that I've done, the amperage seemed to actually kind of either like spike a little bit. It was like slightly increased on the output and compared to the reference. So it was like maintaining the current while increasing the voltage. It was really weird.
Okay, so let's just say it this way. In order to trip the transistor itself, you have to have a certain amount of volts and a certain amount of amps. And if you don't meet that, you're not going to turn it on.
But I don't have a transistor here.
Okay, what do you have?
So this is basically just 3 LEDs hooked up to a resistor. And then that is hooked up to the power rail, right? And then I have a rectifier over here, which is just 4 diodes and a single capacitor. And that's hooked up to the power rail. And that's just showing, the difference that you can use the AC or the DC to power a load and, try to, visually inspect the difference and if it's going to power the fan better or the LEDs better. I didn't know. So I wanted to get a visual of both. And that's basically the circuit. And it's very simple. I use the same number of wires and the same exact, because the number of wires can add resistance, the jumper cables. So I was very careful to try to replicate everything as closely as possible. And it was like when I measured it with the multimeters, it was like you can put the probe right on the output of the stereo amp, or you can put it on the coil itself, the input of the coil, right? And you can measure the input that way, and it's the same.
Okay, but what I'm saying is, even in your motor, there's got to be a trigger point. So either you're not meeting.
Well, yeah, there's a power threshold for sure. Yeah.
Okay, but maybe the meter is not sensitive enough to pick up the milliamp that you need to pick up to get that thing to hit. Okay.
Yeah.
And that's what I'm trying to say. It's when you're putting it through the coil and you're putting that high of a frequency in, you know that you changed it going through the coil, right? Well, it's not going to have the same amount of amps to go between the two coils. So it won't work the same when you get to the end. And if the meter isn't picking up the milliamp that you need, and it could just be 1 little milliamp, that's why it's not running.
Yep. That sounds about right.
You can turn the power gain on a little bit and it'll start running then, when you increase the power a little bit.
Well, yeah, you increase the power.
Exactly.
But you didn't increase the power when you increased the frequency, but then you increased the power and it works. I'm telling you, that's what's going on. You're missing a milliamp that's about to start your system. That's it. Your gauge just isn't accurate enough to pick it up.
Yeah, because LEDs are like 20 milliamps, right?
Yeah.
Yeah, they're very small.
I know when you put more into it, that you get more out. So I'm just trying to tell you how the voltage is working. It's just not showing up like you want it to on your meter. And trust me, mine does it too.
Well, the interesting thing is when I hook up the meter to the correct place, like in my previous video, you'll see the wave pattern is a very big spike. And what Michael kind of noted in our talks, that's in the interview that we have that's not released yet, he was saying like that spike, for some reason, it's showing up on his multimeter upside down. Like he thinks it's supposed to be on the inverse. So that, you know, keep that in mind as well. But it is picking up the huge, you know, spike that we should see, which is, it's very interesting because I don't think anybody else has set up the coil like this and gotten this kind of effect.
Okay. Well, I was just trying to help you, Ben. Wasn't trying to step on your toes.
No, I don't really understand this fully. So that's why I'm asking you guys, you know, like what you think is going on. And that's something that I have to look into. So if it is a milliamp, we need to root that out, right? We need to figure out if that's what's going on or not. So the next step is to try to figure out how we can actually measure this accurately, right? And eliminate that variable.
Well, this is going to sound crazy, but depending on how many light bulbs you have there, it may change it as well because you're putting a heavier load on it or you're lightening the load.
Which changes the frequency, yeah.
So just another thought there. It's an easy thing to fix, to pull one out and see what it does. You know what I mean?
So do you recommend that I pull one out on the reference circuit first and see what it does, or pull one out on the coil circuit?
Pull it out on the second circuit so that you can see if it takes if it gives it more energy to go through it without using as much.
Oh, I see. So if the other lights you know, take the extra energy that it lost and shine.
Yeah. And see if it just, you can pick up that extra milliamp to get you over the threshold.
Right. Okay. No, that's a good one. I'll try that next. I'll put that down.
That's how my coil partially was wrapped. Just so you know, Society of High Sciences. So I wanted to go back to my last video for just a sec because
give me 1 second. I'll pull it up.
Hurley had asked a question or made a comment earlier I wasn't able to get to because Ben was doing his thing and I didn't want to interrupt. He had said that he bet that I couldn't pick up power at 90 degrees. I think it was. I'm trying to find it. You know the pickup coil? Oh, yeah. Okay, so here it is.
Are you sure it's at 90 though? Because you were at close to 90, weren't you?
Well, a 90-degree angle would be at the side of the coil, would it not?
If the coil's flat here and you put a 90 on it, it'd be right here, right? Because your coils are facing this way.
Okay, you're right.
That's where you were hanging though. So if he is he mean the other way?
Yeah, mine wasn't at a 90 degree. It was direct. It was a direct point.
All right. So which direction is he saying?
He says it won't pick up energy at a 90-degree angle, and I have to disagree because I've seen it. I could show it. I'll do a video on it. I will. I'll actually. You know what? That's awesome. John Curley, thank you. You gave me a new experiment. I'm going to turn the same experiment I'll do, except I'm going to take that pickup coil and I'm going to turn it 90 degrees and we'll see if I can get anything.
There you go.
Awesome idea.
Okay. I'm going to show you dielectric in action real quick. Okay.
Okay.
Paper lifter. It's just made out of printer paper. And the top is positively charged and the bottom is negatively charged. And I just want to show you this. As you plug it in, it lifts and then it lets go when you unplug it and it'll stay right there. Now, usually this is done with a, Wimhurst machine, static electricity. This time we're doing it with high voltage. To show you, just plug it in, lifts, and there's a lot of wind that comes off of it. And maybe I'll show it on my fog machine later, but there's a lot of wind that comes off. Okay. And by the way, that's my circuit right there. Just so we understand, It's completely dielectric. There was no wind coming off of it. That was a breeze coming in from the garage. There was no wind. So
Dielectric is beautiful.
just so we understand each other, that's super high voltage with very tiny, tiny amps in it because they run one to the next. And you saw it lift, right?
Yeah.
Now, depending on how far you can put that dielectric close to each other, the two plates, right?
Yeah.
Now you're talking some pressure. But I'm saturating the paper in the middle. And
maybe I'm thinking about this wrong in a sense. Okay, go ahead.
so when I saturate the paper in the middle, then it'll lift. Okay. And it'll always go, okay, from small to big. It always has that direction. There's only one time that it doesn't. And you have to trick the field. You have to think that the weaker side is the stronger side, then it flips. Okay? That's the only way to do that. And
Make it flip?
To make it flip. You got to flip the amount of energy you have to make it flip. Go ahead.
I have one other way. One
Okay.
other way. I don't tell people about this because this goes to half spin. It's one of the abilities to be able to control certain things. Okay. So, if you can control the heat, you control the plasma, the scalar, you can do things with that, right? How do I put that into words? I lost it. Oh, sorry. Brain fart. Go back to exactly what we're just talking about. The dielectric, the charge. Oh, I'm sorry. There's just so much rattling around in this big, thick skull. Half spin. Right. Half spin. Thank you, Terran Earthling. Okay. So if I'm not going to pulse my secondary in the coil system, and I only pulse the primary, I'm basically running the dielectric. Okay. So I've created the dipole. In order to make that dipole flip, on my secondary, I use a capacitor bank and a diode. And then when I want it to flip, I short the cap bank and I half spin the fucker. Every time, man. I can control the flip by doing that. So if I run a circuit instead of, so I'll have it set up to pulse the primary and the secondary, but I won't pulse the secondary. I'll just have that cap and the diode set up. The minute I go to pulse it, it releases all that energy into it and it'll flip it. So there's a couple of different ways depending on the mechanism that you've got.
But hold on.
Go ahead.
You just tricked it into flipping the field. You manually did it.
Yeah. But
I'm saying there's a way to do it without manually doing it.
By raising it enough energy to the point where it automatically flips.
Well, when you push that piezo button, it pushes down just enough to flip that field. So it's the same thing basically.
Yeah.
It just changes the amount of charge on one side versus the other, because on my plate, if you said positive and negative, there's a lot of positive on top and a lot of negative on the bottom, right?
Yeah.
But then when I push it, I take the negative and it pulls up and it takes all my positive out and makes it all negative for just a few seconds. So then it pops.
Oh, you just gave me an idea for a circuit. Oh, yeah. Okay. I need to order a couple of push buttons.
So check it out. I got one more for you, okay? And I just want to...
Go ahead. I'm listening. I'm just drawing this down really quick here so I don't forget it.
Now, this one I just wanted to show because it's showing pressure. Still fucking down to the bottom plate. Now, that's not 1 or 2 grams, by the way. There's no aluminum on this at all, and there's just the aluminum on that side. There's definite force there going upside down, so I'll put it back the other way. And yes, the wind is flowing down and over this. I think this was spinning and this is angled. So, by the way, the foil on this one,
Yeah.
it's on the bottom part. So it doesn't matter if the bottom's flat or it's cone shaped. It matters the size of it. So we see the small one at the top and the big one at the bottom. But as you see the pressure on that, by the way, that's not a few grams. Okay. If I'm bending my ruler in order to move that thing up, I got way more than a few grams there.
Yeah.
So let's just put it this way. There's a lot of force that comes off of this thing when I bring that thing down right before it's about to get any kind of glow or anything like that, or a hissing sound. Man, you can start to get pounds of force out of this.
Really?
And it's because I'm saturating the paper and changing it from a non-conductor to a semiconductor now. Now I'm putting a bunch of charge on it, and now I'm forcing it in one direction with that charge. Now, if I take the diameter of it, as long as I'm smaller than the disc on the bottom that's bigger, I can now thin it and stack them.
You know,
Now I can just multiply the force that I want.
yeah, you know what? You're
It's how a dielectric works. That's why if you really take the time to understand it, you see, every time that it does any sparking or hissing or ion wind, it ruins the effect. It kills it right away. So if you want a high field in there and you want to pull the dielectric, you can make pounds of force on that scale without an issue, as long as you know what you're doing. And it frustrates me when I start seeing little things and they say, oh, this is my field and it's blowing all this ion wind. Well, buddy, your field better blow no ion wind or else you're losing energy because you're just wasting it. You want the dielectric.
Yeah.
So,
well, you know, it kind of makes one wonder, right? As a thought experiment, if you had a coil that was a sphere and charge goes to the smaller hole, you have a smaller hole on the opening of each end of that sphere, and your equator was makes one wonder. I'm just saying, that's all.
By the way, Sean's Tesla coil, that round one, pulls out the exact same field that the Earth makes.
That doesn't surprise me at all. In fact, go ahead.
I was just going to say the magnetic field, the signature is exactly the same, Gerald.
You want to know what I think? I think what Sean has done has multiplied the bottom half. So he's multiplied the Earth's energy. He's not doing what you and I are doing, because the Tesla coil is like the atmospheric energy. Mm-hmm. Same thing with what my system does. I think what Sean's doing is he's pulling the Earth energy and concentrating it. That's why he gets that high voltage, high color. Like, it's insane what he gets, right? So I kind of wonder if he was running that in a thunderstorm, if he would complete the lightning.
Oh. Yeah.
Do you know what I mean? Because his system doesn't work like others.
Even if he just put the grounding rod outside during the lightning storm, his sparks would probably be from the ground to the roof. Like, the amount of energy in the Earth at that point in time is humongous. He might be riding the lightning in his garage at that point.
Big time, right? You'd have to be careful.
Yeah, don't do that one.
Yeah, maybe not.
Oh, man. But I keep seeing, God, newtons of force. And I looked it up. It's 3,000 or 4,000 something newtons of force to get to 1 pound.
Really?
Yeah.
So my little coil lifts 5 times its own weight. What is that in force, I wonder?
I don't know.
You know what I mean? I mean, it's not much. The coil weighs 5 grams. No, sorry. The coil weighs. I have to look at my notes. I think the
I'll
coil weighs.
tell you what it
gram.
means. It means
And
you're
then-
a force to be reckoned with.
Force multiplier. No, I'm just thinking out loud, right?
Oh, hold on.
Mm.
Not newtons of force. It's millinewtons, I think it is.
A
Oh,
million newtons.
millinewtons. So how many millinewtons or newtons would it take for a coil that weighs 1.5 pounds to hop 6 feet?
So hold on. 1 millinewton equals 0.000225. Okay. Do you know what that means? That means that NASA experiment we keep seeing on the things he's doing with the weight control.
Yeah.
I can fart worse than that.
Well, that thing makes me. That guy,
I literally have more pressure in my butt than this guy has going on in the system. It drives me nuts.
I'm sorry. That whole thing where he's doing they say it's all. Oh, it's legit. And, NASA's getting ahead somewhere with that's such a. That guy's. I don't know. If you watch the presentation that goes on, the guy who's presenting exactly what you're saying, and I don't want to say his name or piss on him, so to speak, but that guy always has something to say about somebody else's stuff, and he always brings it back to Einstein. No matter what is out there, he brings it back. We gotta remember the fundamentals. The fundamental principles are very important. We can't stray from them. Meanwhile, your fundamental principles are all correct, but your understanding of them is misaligned. My opinion, one man's opinion, what does it mean? Nothing. I'm just saying, right? But
Yeah.
I don't know. I think that guy's wasting everybody's time personally.
Yeah, I did the numbers on it, and I just looked at it and go, why is he showing this then? Does he have something more that we're not seeing? That's what I'm concerned about. Does he have something more? Because if he did, then it makes sense. And he's just saying, hey, here's a freebie for you, right? But
Honestly,
then he doesn't. Then he goes, okay, when you start telling me how many kilohertz you're putting into a system, and then you tell me you're doing that experiment, we got a problem. Because as soon as you start putting kilohertz into that, you're putting a voltage multiplier on an AC flyback. And what you get out of it at 6 inches, you're getting sparks. If you put it this far close to each other, that thing's annihilated. Okay?
Yeah.
It doesn't even work with a DC flyback. So somebody please explain this to me because it seems just wrong.
Oh,
And-
but they can't. See, because they're academics and we're just simple folk.
No, dude, you're frying the plastic. Yeah. You are literally going to fry that plastic as soon as you hook it up.
We're schmucks.
Yeah.
We're just
Yeah.
all
They're
schmucks.
schmucks. They're all schmucks.
So it can't be a high, either they're using way less energy than what they're saying, or
I don't know.
the
You know
experiment
what?
doesn't work. So
I think it's maybe half of one, half of the other. I kind of got the gist of the experiment and how they're doing it. He's trying to get that point before it sparks where it's just plasma, like a purplish glow, so to speak.
the ion wind, yeah, it's a waste of
Yeah.
energy.
But again, like you said, it's a waste of
Oh
energy,
my
right?
God. Do you know how frustrated it makes me that people do not understand the states of energy after the amount of times that I say it?
But this guy works for NASA. Does he not understand? Or does he understand? And he's telling you what he wants you to hear.
I don't know.
What-
He works for
what-
NASA,
what
and they
did you
lost
do?
the technology to go to the moon. So,
You know Listen, if they ever did have it, and I believe that they did, or at least it's possible, I don't think they lost it. They packed
no,
it
that's
away.
just that's the public explanation. Like
Yeah,
I've
it's
seen
a-
clips of because they go live sometimes and they'll have their astronauts, talk about like, in the, International Space Station or whatnot. They'll be like, oh, this is why, we can't go back to the moon. They've straight up said, oh, they lost the technology. I'm like that. I'm
How
like,
do you
seriously?
freaking lose? how do you lose a piece of history? Either one, you're incompetent, or two, you're a fucking idiot. Sorry,
Okay.
it's history.
Let me just say that guy was a moron.
Yeah,
Because they actually have a satellite that goes around the moon, and it shows all the different sites where we landed on the moon, by the way. So just for all your
It shows
conspiracy
a lack of
theorists out there,
critical thinking. Yeah,
they
it shows a lack
literally
of
have a
critical thinking.
satellite that orbits the moon.
See,
Yeah.
that's why I say I believe it's possible. I haven't seen the evidence or proof, but I haven't seen the proof otherwise.
Well,
I've
I
seen
think
a
he was
lot of
specifically talking
documentaries
about.
on them doing videos, but they used to do that on top of what they were doing. So
I think they were in the video. From what I can remember, they were specifically talking about like how they bypassed the Van Allen belt. But at the same time, you know,
yeah,
like
that is a good point. But
Well, I don't know. We got rovers on Mars. We have what is it? Is it Japanese rover that's on the moon right now?
yeah,
right.
And then
But at
we
the same,
just put,
yeah, it's
we put
if you
one
just-
up that went sideways up there.
yeah, it's just you know if you like don't take the BS like story that's been spoon fed. You know, and you think a little critically, you know, you'll come to the realization that they didn't lose it; they just don't want us to have it.
well, they
Yeah.
don't want to do any more trips. I guess I don't know.
Well, what I find funny is they came out with the Mars rover, and first thing I saw was they found a puddle so that you see the tracks went through mud.
Yeah,
And they had to explain that and say there might be an ocean on there. Then you look at the actual footage that they say of what Mars looks like now, and you're going, okay, Mars is more like Earth than it is a red planet. So that whole red planet thing was a lie.
Didn't the original pictures? I heard something like the first pictures that came out were like a different hue, and then they soon after applied some kind of filter
They
to
did.
make it look more reddish.
They did.
Hmm.
So
yeah. Ultimately, you know what it comes down to? We have to trust everything that we're given when it comes to pictures and satellite feeds and this, that, and the other. And who's the one giving it? NASA. What does NASA stand for? Never a straight answer, because they never give you one. I don't care who you are working for NASA. There's been independents that have gotten contracts through NASA. Half of them have done really amazing work. The other half, just blowing hot air. What have we seen from it? A paper? The paper goes into academia. Public doesn't see shit. We don't do anything with that information. So why are we spending so much money to support NASA when they're not doing anything?
well, I think that's the thing. They are doing it and they're not telling us.
That's possible too. Maybe I'm just a dumbass.
Well, they're keeping us
possible.
they're keeping us distracted with the live streams from the International Space Station. That's honestly what they're doing. You know.
You know what? It's the oldest story in the book. Look what's happening. Meanwhile,
Exactly.
the other guys are
Misdirection. Yeah.
Okay, just so you guys know real quick, newtons of force is a time measurement to pass the mass 1 meter per second. By the way, I made plasma channels ion lifter. Okay. And I'm going to tell you it runs at 2.4 meters per second. So if they even had a Newton of force, they still lost their butts to the plasma channel. Okay. Sorry. It's just that, and he multiplied his and he got that sucker up to, I think, 4 or 5. So, yeah. So this right here, if he has millinewtons, then, like I said, man, my farts are harder than that.
Yeah, I don't know.
I could probably blow a horn with my fart
I shake my head
louder than that.
Yeah, I shake my head at the work that's being done. Like, oh man, I could get into it. I'm trying not to step on too many toes, but there's some experiments going on where people just got inherited like thousands of dollars of equipment in order to do something called NMR. You know what NMR is?
What's
It's
that?
aligning a freaking magnet, man.
That's it?
It's making the material in your area of your system polarize. So I'll give you an example. I spin magnets. I could spin magnets like this, or I can spin them on their pole so that they spin like this, okay?
Mhm.
I have a problem when I get past 5 volts because I got the magnet sitting on the table and it's spinning like this, or it'll rock and spin at the same time. It always polarizes like that. I can't stop it. It's impossible. Not only does that magnet polarize, but if there's magnets on the outside of the coil, those polarize. And all the coils that I use for pickup coils, those polarize as well. How can I tell? Easy. If I flip one of the lines on one of the coils, I don't get nothing out. So what does that mean? I've accomplished NMR with 12 volts and about $100 in meters, rather than thousands of dollars equipment to try and do something that they have not done yet.
Didn't Floyd
Not
Sweet
bragging.
do
Please
something
don't
similar?
take it that way. I just think they're looking in the wrong direction, and their arrogance is what's stopping them. Anyway, sorry. Go ahead.
Oh no, I was just saying, didn't Floyd Sweet do something similar? He like constructed his magnet in a specific way, and he didn't have like hundreds of thousands of dollars in equipment, you know?
Floyd Sweet was a genius. He created a high voltage geometrical form to create magnets. Whoa.
Yeah, I believe there was a lecture that I was watching. Somebody who had a theory on the magnet that Floyd Sweet used, and they said that he constructed it in a very particular way, where like the blotched wall was like off or something.
Yeah, well, see, the blotch wall is important in my system. I got to stop saying my system. I'll say it like this. The system for the world, in the center of the coil where the open core is, I've compressed all the blotch walls into one circle. That's what it is. That's the center of the open core.
That makes sense.
Like I said, when I wrote this paper in this last week, and I just finished doing the last revision, it talks about that and the null zone or the depletion region. And I got videos to match with it now. So it's going to be cool when it's done. Yeah. Getting there. But everybody in the scientific community is putting out videos talking about certain things like the Zitterburger gun, which is just a load of crap for ether. Basically, the molecules are the nodes that are moving and shaking in the ether. That's all.
What do they call it?
Zitterburger. It was something that Richard Feynman came up with. I told the story on one of the lives. He was basically making fun of his students and threw that name out there just to show his cohorts how stupid his students were. They laughed and said there's no way they're going to fall for it. He put it in a paper, and now it's a big deal. And people are going, Zitterburger. You got to have the Zitterburger. You know what it is?
Oh, my God.
It's a word, man. That's all it is. It's a word for ether.
Oh. That's it. Fringe Think Tank is going back with the Zitterburger gun and going through the transporter.
That's it. That's it. And
well, I mean,
the other stuff, like I'll give you for instance, the video that I put out today that we were talking about earlier, that if I'm correct, and I've had somebody else bring this up to me, that very video shows the Aaron-Hoff-Bohm effect. So what it shows is two waves interacting, cross-interacting and producing a voltage or producing an output. So that's the big thing that they're looking for, is to have two waves cross and be able to control what comes out after. Because what comes out after is the ether. So if you can control that and place it where you want, build a bubble, you now have a system that's going to make you fly, or allow you to fly, I should say.
No wonder why they wanted to steal it from you.
Well, you know what? In the last 3 months, I've watched the scientific community describe this system at length, and it's all different theories that come together all in one. But it's basically a system, right? It's a dynamic system. It's not one thing, two things, three things. It's, like I said, 7 to 12 things actually that come together to make it work. So, but it all has to do with Tesla, man. Tesla was a genius. He started it. He had it in his Tesla coil. That's where this all starts. Well, I shouldn't say that's where it all starts from. It starts in thousands of years ago, in my belief. But that's
yeah, I could tell you from pulling those mandalas, it started a long time ago.
I think they had force fields back then. I think they had free energy. Sorry for the word. They had over an abundance of energy. I think they had lighting. I think they had systems. This narrative that we were cavemen back in the day, I don't buy it. I'm sorry. I just don't buy it. People are smart. They're not dumb. They choose to be dumb because they don't want to deal with the stress that goes around with being intelligent. But people aren't dumb. They're very smart. They just choose to be lazy, I guess. I don't know. In certain instances. Not all, but some, right?
Well, it's the top not wanting the bottom to know, because you do know that when you control this type of system, the power and responsibility that comes with it is just enormous. And
with
when
great power comes great responsibility.
If you start like these people do and build hydrogen collider size things, you ruin the whole world. So I'm surprised we're not ruined more, because as soon as they turn that stupid thing on with all the magnetic fields in it, our planet starts to go haywire, and they blame it on global warming. Oh, you're having problems with your atmosphere because of global warming. They're not. Turn off these stupid colliders and we'll be all right.
Yeah.
Because you're messing with the earth.
There's 3 YouTubers, and I won't mention their names because I don't want to get them called out, but if you search, you'll find these guys. There's 3 YouTubers that have correlated every time it fires up a shift in our magnetic field and a shift in weather patterns. Every single time. Go figure. Coincidence? Does causation cause correlation?
Yeah, and we're not getting a whole lot out of them. It's a waste of money.
Yeah, it was a waste of money to begin with.
It's just screwing up Earth.
Yeah.
It's like these morons that want to put bases on the moon. Hello, let's not put anything up there that somebody else wants to blow up.
Right.
You know what I mean? We kind of need the moon.
You gotta have one base, you gotta have 13 bases or 40 bases, because everybody wants a base up there.
Yeah.
I want a base up there.
I want them to not touch it. Leave it alone.
Yeah.
Yeah. Preserve it,
agree.
you know?
Yeah, 100%.
There could be a lot of details of, you know, like the history of our solar system just, you know, on that planet's surface. So
it's weird. This generation seems to want to kind of destroy our history when it comes to certain things and certain connections to our past. You know what I mean? I hope that's not the case. I hope they don't succeed, but I'm not willing to let them easily. What do they say? What is that Dylan poem? Do not go gently into the night. Fight against the dying of the light. Yeah, absolutely.
Yeah.
100%.
Learn history and know it so you don't repeat it, you know?
Yeah, absolutely. So, yeah, when you're talking about ground, Nathan, and putting the energy into the ground, tune the ground, and then you have that upper space going on, kind of sounds like maybe a pyramid.
Yeah. I think it's all tied in.
Yeah. Yeah, I believe it is 100%. I believe that. What?
No, go ahead.
I was just going to say every pyramid had its own force field. And in that force field, it grew food 3 times as fast. I know that for a fact. And it was more lush and bigger, more nutrient. And I believe that they had an abundance of water at any time. In fact, I believe they had to make channels and pass for this water to flow because it was coming no matter what. Yeah. And I think that was a time where the world lived in abundance. I think that this is all one man's opinion, that Atlantis wasn't a place, one specific place. I think it was a worldwide system. Everybody had it. And it just broke down through a series of unfortunate, crazy events.
Yeah, that is a one of the theories that I was learning about was that Atlantis was spread out like in a system of different islands throughout, the Atlantic and possibly connecting different cultures that way,
Mm-hmm.
Absolutely. Is there somebody else who's come up with this theory? Because if there is, I'd love to hear about them. Is there a person named Interstellar? Because I'd check out their channel. In fact, maybe invite them on. All that came from just my knowledge. It wasn't somebody's channel.
Oh, I think he's talking about the movie. That's a movie.
Is it a movie? Really?
Yeah, if you haven't seen it, it's really good.
I mean,
I don't really remember it that well.
I mean, gotta watch it to say, right? Even though I'm talking about myself here. You guys missed what I said, so I don't want to repeat it though. It was the R word, right? But no, if Interstellar is a movie and it's the same sort of points that I brought up, maybe there's truth to it. Maybe it was like back in 2011, 2012, the big hype was that movies were used as leaderboards for the elite to bring out information to the public that the public would never accept. That way, on the day of their judgment or atonement or whatever you want to call it, they would be able to say, well, we told them, we made a movie about it. But they didn't.
So it was like preconditioning almost.
Kind of. I don't know how true that is. It's just sort of a thought came to mind. Thought I'd bring it up.
That's interesting.
Don't know. Maybe my hope will come true one time. It'll be Star Trek, and that's where they got it from. We'll be on a starship soon enough.
Wouldn't that be amazing, eh?
Oh, God, can you imagine us a bunch of morons out there in the universe screwing things up?
With an apple coil.
Oh, that would be just awful. And
I don't want to do anything crazy. Just make a planet. Come on, what's wrong with that?
Oh,
I just want to eat some magic mushrooms from a different solar system.
I think we all want those magic mushrooms.
Right? That's awesome. Lulu agrees.
Yeah. Oh, my.
That'd
be something else. Well, at least we know how to fix the ship. We wouldn't be in trouble there.
There you go. Well, see, if you had a ship, everybody would have to be an engineer. You couldn't just have one guy or one group. You would have to switch jobs all the time. That way, everybody knew how to do it. Because if you lose one person,
and you would design the ship so it only have 3 holes.
Oh, you got it in there,
Canadian. Dude. The ship's not Canadian. You can't have 3 holes. You gotta get Mike in or get a 4th.
Bunch of schmucks have 3 holes.
That's right. We'll get Admiral.
My schmuck hole.
Oh my. Oh.
That's awesome. So,
all right, guys, it's getting late. We're already past the 2-hour mark.
Yeah,
so Gerald and Ben circuits.
I was just looking at that actually. Yeah, I'm not showing you my circuit I just drew. It's not good. Okay, but I know what it means.
Not another one, huh?
It's really not good, but I do know what it means.
Gerald always puts some good headlights in his circuits.
Yeah, where there's always a hole. It's for the coil. Come on.
Gerald's always playing with the hole in his coil.
Do you want just the Jewel Thief circuit, or do you want the circuit that I use to power the fan and the LEDs?
Yeah, both those circuits.
Both of them? Okay. I'll have to throw together a diagram for the other one, but that shouldn't be too hard.
Yeah, and they don't have to be perfect, guys. Just a quick, hey, this is where it goes, and you know what I mean? Because I'm gonna run it and put it on the whiteboard for everybody.
Okay.
Yeah, well, I'll probably what I'll do is I'll just do a small video to send to you, and it'll be on the whiteboard. You can do whatever with it.
Okay.
Yeah. It's probably the easiest way to do it for me anyway. I don't know.
You could just record it in StreamYard and leave it there, and I'll go back in and
Oh,
find
yeah, right. Okay. I'll do that. That'd be easier.
Yeah, that's
Yeah.
a good idea.
Awesome. That is awesome.
All right, guys. Wednesday we have a show about circuits, and we have a bunch of circuits to go over to. Apparently, and hopefully everybody has them done. And I'll go ahead and put the flow diagrams, and I'll find all the parts. And what else you guys got going on your channels?
I'm tempted to show the sphere. Not sure if I want to yet. I'm doing.
Oh, you got a sphere coil?
Yeah, and
Oh.
I'm really excited over it. But I'm still doing tests with it, so I'm not sure if I want to show that just yet. Maybe I'll show the water coil. Maybe I'll show that on Wednesday. We'll see. I'll show something.
Well, I think most people would agree with me. Just show the circuits, and we'll be all right.
I'll send you the circuits. You show them. I'll show something else. How about that?
There you go. Huh.
That's
All right.
awesome.
Ben's got that apple. Okay, hold on. We got to address it. When are you blowing up that apple?
Whenever I get some C4.
Well, don't say that. You're getting us all in trouble.
No. I'm
Speaking of
kidding.
which,
I'm
I just
kidding.
got a whole bunch of little capacitors, and I used to take my coil and blow them up. They shoot off like Black Betties or little firecrackers, right? So I want to try and make a song by firing them off.
Oh,
Or something
That's
like that.
cool. Yeah,
just
you could
reminded
do
me of
that.
I'm going to try and put that together for
That's
Wednesday.
a good idea.
Yeah, I'll try
That's
and
a
put
great
that
idea, Joe.
so hold on. Are you saying take a pretty decent sized capacitor, put a hole in that apple, and shove that capacitor in the hole?
Oh.
Yeah, it'll be an a-hole.
That's good. That's good. It'll be asymmetrical, right?
I walked right into that.
Yeah. As long as you're not backing into it, I'm sure you're fine.
So I want to try to blow it up in some interesting way. I haven't figured out a way though.
Oh.
We used to put firecrackers in our Lego when we were kids. Man, it was awesome. You build like a big house and then light it off
Something
and
like
watch
that.
it.
But until
Right? Having fun.
we figure out how we're gonna blow up the Apple coil tomorrow, if all goes to plan, we have a live stream on my channel where Shanjax is gonna come on and walk us through the circuit that he built, the modified Bedini SG circuit, which is gonna be really cool. And I think Charles Milligan wanted to get on that as well. I'll have to get in contact with him. So and also I'm not sure when. It'll probably be in the next couple days, but I'll have the first episode of the sesh, which is featuring Michael Morell for the first episode. It's a pre-recorded session where we go over some of his research because he's in a different time zone. He wants to join us, but he has trouble too. So this is a way. And then we're going to be doing more of these sessions pre-recorded. I'm going to be interviewing Nathan probably next, and then Gerald. And if you want to get on and have like a fun pre-recorded session. Just an interview, about some of your research and, talk about maybe how you got into this and stuff like that.
Yeah,
that'd be really
that's a
cool.
long story.
All right. Well, that's all I got.
Yeah, I think I'm going to do that. I'm going to actually talk about my past and the stuff that I went through and what led me into this. But I don't know if I want to do it on my channel because my channel's mostly science and experiments. And this
We can have it on the sesh. Yeah.
Spiritual and crazy stuff.
That'd be actually perfect for what Ben's doing. Yeah.
There you go.
Because people want to hear your story, I think. So
Tell you about the time a bear almost ate my head. Yeah.
Oh boy.
There's a time I flipped the trike while I was doing like 30 through a bush. I hit a tree and
wow.
Literally voice went off and said duck and tuck. I pulled my head into the handlebars, tucked my body down. The trike hit the tree. It flipped over, hit the back tires, and pulled me back over. And I literally pulled my head up and was rolling forward. Literally did a flip over the tree. Didn't mean to, wasn't trying to, could never do it again. But one of the things that happened to me when I was a kid, crazy stuff my whole life like that.
Well, that should be an interesting conversation or interview, you know.
Maybe. I'll try not to put you to sleep.
I don't think that's going to happen.
Yeah,
I'll tell you how we rode the belt sander in the backyard.
just wanted to do that. Never had the guts. That's awesome. That's awesome. Yeah, man, I want to hear about that for sure. You got
Good old time.
This channel for sure. Yeah. The only thing I did like, well, no, not like that. We used to go on shopping carts and push each other down the hill into a creek to see who would hit the water first. But we never rode. I always wanted to ride a sander. I always thought that was the most awesome idea.
Oh, man.
Yeah.
We all grew up around a cabinet shop, so we'd take the saw blades and throw them like ninja stars at the tree. And then my brother shot himself in the foot trying to hit a beetle. He says to this day he wasn't doing it, but he took the safety and he cocked it back and held it with wire, right?
Yeah.
So he could shoot it at will. And it landed right on his foot, and he thought, I got it now. 16 penny nail right through his foot. And it's like,
Oh.
Yeah. So my other brother turns around and goes, okay, we're not going to tell mom and dad. Let's get the pliers and let's get dad's alcohol. So they come out here with this big bottle of booze, right, and a pair of pliers. And they go, well, they're pouring it on there, and they go, oh, you can't just pour it on there. You got to give him some of this, right? Because he needs it for the pain. So here he is with a nail in his foot, alcohol all over his foot. He smells like booze, okay? And then my parents come home, and he's already drinking some of the booze. Let's just say he was drunk in the ER, getting the nail pulled out of his foot and stitched up, and we all got a whooping for that one.
Oh, yeah. Yeah, because he touched the old man's liquor. Oh, that's funny. That's awesome, though. See, the stuff we do when we're kids. Kids
Always
these
fun.
days don't do that stupid shit. I don't know why. They should. That's how you learn, right?
Oh, man. All right, guys. Thank you very much for showing up today. I appreciate everybody sticking around and listening to our war stories. Really do appreciate it.
Appreciate you guys. Thanks, Nathan.
Yeah.
Thanks, Gerald.
You guys rock that are out there. Love the comment section. We've got high intelligence in our comment section.
That's right.
Ben, you're doing good work. Nathan, you're awesome. We all love you guys.
Appreciate it.
We'll talk to you soon out there.
Right
Thanks,
on.
guys. Thanks, chat.